Is it true to say that the area of a square inscribed in a circle of diameter p centimeter is p square centimeter square and y? So guys, very first thing to you guys is, very first question is, what are the possibilities? What is the possible diagram? Is it a square outside the circle, something like this? Or is it a square drawn inside the circle? That has to be very clear. Yes, it's the square inside the circle. Square inscribed in a circle. Okay? If you don't understand the word inscribed also, just understand the word in the circle. I'm sure that you guys do. And we have the diameter to be of p and all of that. So that's okay. So this entire length is, again remember I drew the diameter and also the diagonal of the square. Okay, and the length happens to be of length p centimeter. And now on to calculating or showing the calculation. How will we find the area for such a square? So area of the square is given by what? A square. And also what? Half the diagonal square of the diagonal. Okay, how did I get this? I'll show the derivation or explain the logic behind this a bit later at the last. If you guys know it, good. If not, don't worry, I'm explaining this. So we'll substitute over here. What is the substitution? Well, the length of the diagonal over here happens to be the length of the diameter. Agree? Okay, and so we have this to be equal to what? P. And therefore the area of the square is equal to half of p square. Okay, so that's your answer. And people who have a doubt on the formula, so this is how it is. See, area of the rhombus, you guys know, is the product of half of the product of diagonals. Okay, yes, remember these are your diagonals of the rhombus. Now, a square is by default a rhombus. A square is a rhombus. Okay, all the squares are rhombus, but not all the rhombus are square. And therefore, we have the following formula. That's it. So here d1 and d2 are of same length when we're talking about a square, and that length we can call it as d, and so the formula will be diagonal square.